Warm welcome you all to channel Meet MIT, that is Math is Tricky.
In this video, I'm going to share some tips and tricks for differential equation in linear form, and I'll be solving some differential equation in linear form. Okay, so let's first try to understand what is linear form and how do we solve the problems of differential equation in linear form. Okay, so the linear form is the differential equation which will be in the form dy by dx plus py equals q, where p and q are functions of x or constants, but not of y. It is easily integrable if both sides are multiplied by a factor that is called integrating factor, and the integrating factor is given by e power integration of p dx. Okay, in some special forms, in some cases which may be in the form dy by dx plus py equals qy square. Okay, we should change it in the form, let's divide this type of differential equation by y square on both sides. Okay, so let's make in q only in right hand side and bring all the terms to left hand side and change in this form. Q equals y to the power minus 1 dy by dx plus py power minus 1, and in that case we have to substitute 1 by y, that is y power minus 1 equals z, so that we'll be getting here on differentiation on both sides. If we differentiate 1 by y equals z with respect to x, we'll get here 1 by y square, that is y power minus 2 dy by dx equals minus dz by dx. And from that, if you put the value of 1 by y square dy by dx in given equation, we'll get minus dz by dx and plus p, because y power minus 1 is z, and equals q, and we can take minus common, so that we'll get dz by dx equals pz equals minus q, and which will be again in linear form, and we can easily integrate this. Okay, so this is about the linear form. So remember, dy by dx plus py equals q, where p and q are functions of x or constant only, not of y. Okay, so remember that. And to integrate this type of problem, we have to find the integrating factor, which is given by e power integration p dx. Okay, so this is a little bit information or short note, or you can say here short concept and short ideas about linear equation. Now let's solve the problems so that it will be more clear to you. Okay, so let's see the first problem. Question number 1 is dy by dx plus 3y equals e to the power minus x. So if we compare this with the linear form dy by dx plus py equals cube, we get p equals 3 and q equals e power minus x. So as we discussed, to solve this type of linear equation, we have to first find integrating factor. So let's find integrating factor. It is given by e power integration p dx. So e power integration p is 3, dx integration of 3 is 3x. So now let's multiply both sides by e power 3x, that is by integrating factor. Let's multiply the given equation, so that we'll get here e power 3x into dy by dx plus 3 e power 3x y equals e to the power 2x, because e to the power 3x into e power minus x means e power 3x minus x, it is e power 2x. Now if we see carefully, left hand side goes in the formula of product rule, that means product rule for differentiation. So derivative of y into e power 3x plus derivative of e power 3x into y, that is derivative of first into second plus derivative of second into first, equals, we can write here e power 2x dx. We are taking LCM, so that we are getting e power 3x into dy plus 3 into e power 3x into y dx equals e power 2x dx. Now we can see that left hand side is the formula of y into e power 3x and right hand side is e power 2x into dx. Now by integrating on both sides, we will get here y into e power 3x in left hand side equals integration of e power 2x on right hand side, which is e power 2x by 2 plus c, and by simplification or dividing both sides by e power 3x, we'll get here y equals 1 by 2 e power minus x plus c into e power minus 3x, which is the solution for question number 1. Okay, so let's move to question number 2, and here it is. The question is dy by dx equals 3 by x, y equals 9 times x power 5. So if we compare this with the differential equation in linear form, dy by dx plus py equals q, we get p equals 3 by x, q equals 9 into x power 5. Then we need here integrating factor to integrate this, to solve this linear equation. So let's find the integrating factor, and integrating factor is given by e power integration p dx. So put the value of p, it is 3 by x, and integration of 1 by x is log x, so we'll get here e power 3 log x, and we can use formula of log, one property of log, x power log x power m equals m log x. Okay, so we can write here e power log x cube, and e power log x cube is same as x cube. Okay, so multiplying both sides by x cube, we will get here x cube dy by dx plus 3x square y equals 9 into x power 5 plus 3 8. Okay, x power 8. So now let's take LCM, so that we'll get here x cube dy plus 3x square dx into y equals 9x power 8 into dx. Now we can see that left hand side goes in the formula of u into v, so it is derivative of first function into second function plus derivative of x cube into y, that is derivative of second function into y, and right hand side is as it is. Now left hand side can be written as y into x power 3 equals 9x power 8 dx. Now integrating on both sides, we'll get here y into x cube equals integration of 9x power 8 dx, which is 9 times x power, let's use power rule, so it will be here x power 9 by 9, 9 and 9 cancel, so we got here y into x cube equals 9x power 9 plus c, and by dividing both sides by x cube, we'll get here y equals x power 6 plus c by x cube, which is the complete answer or the solution for question number 2. Now let's move to question number 3. So my dear students, in this video we are discussing about differential equation linear form, and we are solving it. Okay, so hope you are understanding this. Let's see here question number 3. Here the question is x dy by dx minus y equals 2x cube. So let's change this in linear form. So dividing both sides by x, we'll get here dy by dx minus 1 by x into y equals 2x square. Now by comparing this with linear form, we'll get here p equals 1 by minus 1 by x cube equals 2x square. Let's find the integrating factor, which is e power p dx integration e power integration p dx. So it is here e power integration of minus 1 by x dx, which is integration for 1 by x is log x, minus is there, so minus log x, and we can write here e power log x power minus 1. Again we are using one property of log, so it will be simply x power minus 1, that is 1 by x. Now multiplying both sides by integrating factor will get here. So please be careful while multiplying by integrating factor. So the equation in norm, the equation which is in linear form will be multiplied by integrating factor. Okay, so we'll get here 1 by x into dy by dx minus 1 by x square y equals 2x. Now if we take LCM, we'll get here 1 by x dy minus 1 by x squared y dx equals 2x dx. Now we'll try to express left hand side as the derivative of some function. So it is here derivative of y into 1 by x plus derivative of 1 by x, which is minus 1 by x square into y equals 2x dx. So now left hand side can be written as derivative of y into 1 by x, and right hand side is as it is, and right hand side is as it is. So now by simple integration we'll get here y into 1 by x in left hand side equals integration of 2x dx, which is x square plus c, and hence y equals x cube plus cx, which is our answer. This is solution for question number 3. Now let's check question number 4. So question number 4 is 1 plus x square times dy by dx plus 2xy equals 4x square. So let's change this into linear form. So that will get here by dividing both sides by 1 plus x square, we'll get here dy by dx plus 2x by 1 plus x square times y equals 4x square by 1 plus x square. So by comparing this with linear form, we'll get here p equals 2x by 1 plus x square and q equals 4x square by 1 plus x square. Now let's find the integrating factor by formula e power integration p dx. From that we'll get here e power integration of 2x by 1 plus x square dx, and in this case derivative of 1 plus x square is 2x, so simply it is integration of log 1 plus x square. So by integrating 2x by 1 plus x square we'll get here log 1 plus x square, which is simply 1 plus x square. Now multiply equation 1 by 1 plus x square on both sides, we'll get here 1 plus x square dy by dx plus 2xy equals 4x square dx. Okay, so by taking LCM we'll get 1 plus x square dy plus 2xy dx equals 4x square. Now we'll express the left hand side as product of derivative of product of two terms. So it is derivative of y into 1 plus x square. Simply we'll get here, so left hand side can be written as y into 1 plus x square, and right hand side is same, or just we'll copy it. So 4x square dx. Now integrating both sides we'll get here y into 1 plus x square equals integration of 4x square, which is 4x cube by 3 plus c. Therefore the required answer is 1 plus x square into y equals 4x cube by 3. This is our complete solution for question number 4. So my dear students, in this video I'm discussing, I'm sharing some ideas and solving the problems of differential equation in linear form. Hope you are getting this, hope you are understanding this, and please, if you have any confusion or any suggestion, you can share with me, write it in comment box. And if you have not subscribed my channel till now, please subscribe it and also hit the bell icon so that you will be notified as soon as I'll be uploading the video. Okay, so now let's solve the question number 5. So the question is here x plus 1 dy by dx plus 2y equals ex by x plus 1. So dividing both sides by x plus 1, we'll get here dy by dx plus 2 by x plus 1 into y equals e power x by x plus 1 whole square. Now comparing this with linear form, we'll get here p equals 2 by x plus 1 and q equals e power x by 1 plus x whole square. So let's find the integrating factor. So that we'll get here integrating factor equals e power integration p dx, which is e power integration 2 by x plus 1 dx, and which is simply integrable, and we can easily integrate this to get the result as e power 2 log 1 plus x, which is e power log 1 plus x square, and which is simply 1 plus x whole square. Okay, so now multiplying equation 1 by 1 plus x whole square, we get here 1 plus x whole square dy by dx plus 2 1 plus x y equals e power x, and if we take LCM here, 1 plus x whole square dy plus 2 into 1 plus x y dx equals e power x dx. Now we'll express the left hand side as product of two things, and it is always remember it is simply y into integrating factor. Okay, so we can see here left hand side is derivative of y into 1 plus x square equals e power x dx. Now by simple integration, integrating both sides, will get here y into 1 plus x whole square equals integration of e power x is e power x plus c. Therefore 1 plus x whole square into y equals e power x plus c is our answer. This completes the solution for question number 5. Now we'll move to question number 6, and in this video we are discussing about differential equation of linear form, and we are solving problems based on it. My dear students, it's not difficult. You need to change the given equation in the linear form and then find integrating factor and then multiply both sides by integrating factor. Then always left hand side will be changed as y into integrating factor equals integration of right hand side, and then from that we'll get easily we'll get our answer. This is what I'm doing. So now let's solve question number 6. So dividing both sides by sin x, we'll get here dy by dx equals cos x by sin x is cot x times y equals cos x. Okay, so comparing this with linear form, we'll get here p equals cot x and q equals cos x. So let's find the integrating factor. So we'll get here e power integration p dx, which is e power integration of cot x dx, and we know that integration for cot x is e power log sin x. Okay, so and which is simply sin x. Now multiplying both sides by sin x, we'll get here sin x dy by dx plus cot x is there, means cos by sin cancel, so we'll get here cos x into y equals sin x cos x. Now by taking LCM, we'll get here sin x dy plus cos x dx into y equals multiplying up and down by 2, will get here sin x 2 sin x by 2, and now we can write here y du. This is left hand side. Let's try to convert or change the left hand side as product of two functions. So it is simply derivative of y into sin x equals sin 2x by 2 and dx. So like now simply integrating on both sides, we'll get here y into sin x equals 1 by 2 integration sin 2x dx. So we can write here this as y into sin x equals 1 by 2, the integration of sin 2x is minus cos 2x by 2 plus c. Now we get here sin x into y equals minus 1 by 4 cos 2x plus c. So let's bring the term cos 2x by 4 in left hand side, so that will get here sin x into y plus 1 by 4 cos 2x equals c. This is our answer for question number 6. Okay, so hope you are understanding this, hope you are enjoying this video, and if you like this video, please share among your friends. So simply now we'll move to question number 7. Question number 7 is tan x dy by dx plus y equals sec x. So by dividing both sides with tan x, we'll get here dy by dx plus cot x y equals cosec x. So cos sec x is 1 by cos, and tan x is sin x by cos x. So we'll get here, as if we divide by tan x, we'll get here dy by dx plus cot x y into y equals cosec x. Now comparing this with linear form, we'll get here p equals cot x and q equals cosec x. So now let's find integrating factor. So it is e power integration p dx, which gives here e power integration of cot x dx, and which is simply e power log sin x, and which gives here simply sin x. Okay, so multiplying equation 1 on both sides by sin x, we get here sin x dy by dx plus cos x into y equals, if we are multiplying by sin x, it will be simply 1. So left hand side is derivative of y into sin x, and in right hand side we are getting here 1 into dx. So integrating both sides, we get here y into sin x equals x plus c, that is sin x into y equals x plus c. That is our answer for question number 7. It's not difficult, my dear students. You can do by yourself and just take the ideas. So once again, explaining the steps. The steps are: you first change the given equation in linear form, and then find linear form is dy by dx equals py equals q. Okay, so after changing that, you find the integrating factor by the formula e power integration p dx. Then after getting integrating factor, you multiply both sides by integrating factor. Then always your left hand side will be changed in the form derivative of y into integrating factor equals something. Now integrating both sides will get here the answer, required answer. So now we'll move for question number 8, and here it is 1 minus x squared divided by dx minus xy equals 1. Dividing both sides by 1 minus x squared, we'll get here dy by dx minus x by 1 minus x squared into y equals 1 by 1 minus x squared. Let it be equation 1. Comparing this with linear form, we'll get here p equals minus x by 1 minus x square and q equals 1 by 1 minus x square. Let's find the integrating factor. So it will be, integrating factor will be given by e power integration p dx, which is simply e power minus x by 1 minus x square dx, which gives here minus 2x by 2 into 1 minus x square, multiplying up and down by 2. Now it's simply integration of 1 by 2 log 1 minus x square, and because here derivative for 1 minus x square is minus 2x. Okay, and so 1 by 2 means we can write here log of root 1 minus x square, and so we'll get here simply this can be simplified as square root of 1 minus x square. Multiplying both sides by 1 minus x square, square root of 1 minus x square, we'll get here 1 minus x square divided by dx minus x by 1 square root of 1 minus x square, and then into y equals 1 by square root of 1 minus x square. So left hand side, by taking LCM, we'll get here 1 minus x square, square root of 1 minus x square into dy minus 2x by multiplying up and down by 2x by 2 1 minus x square into dx into y equals 1 by square root of 1 minus x square into dx. Now left hand side is derivative of y into 1 minus x, square root of 1 minus x square. Left hand side is derivative of y into square root of 1 minus x square, we can see easily. And then right hand side is simply 1 minus 1 by 1 minus x square under root into dx. So integrating both sides, will get here 1 y into 1 minus square root of 1 minus x square equals integration of 1 by 1 minus x square dx, which is simply sine inverse x. Therefore we'll get here y into square root of 1 minus x square equals sine inverse x plus c. This is the required answer for question number 8. Now let's move to question number 9. And the question number 9 is here. It is dy by dx plus 2x by 1 plus x square times y equals 1 by 1 plus x square whole square. Okay, so it is in linear form, so just by comparing we'll get here p equals 2x by 1 plus x square, q equals 1 by 1 plus x square whole square. So let's find the integrating factor, so that we'll get here e power integration p dx, which is e power integration 2x by 1 plus x square dx, and simply it is here log 1 plus x square, and which is 1 plus x square, multiplying equation 1, given equation by 1 plus x square on both sides, will get here 1 plus x square y dy by dx plus 2xy equals 1 plus x square. Now let's take LCM, so that we'll get here derivative of y into 1 plus x square plus 2x, means here it is derivative of 1 plus x square into y, and right hand side will be dx by 1 plus x square. So now we can write here left hand side as derivative of y into 1 plus x square equals 1 by x square into dx on right hand side. Now integrating both sides, we get here y into 1 plus x square equals integration of 1 by 1 plus x square, which is tan inverse x plus c. Therefore y into 1 plus x square equals tan inverse c, tan inverse x plus c is our answer. Now let's move to question number 10. Okay, so my dear students, in this video we are solving problems of differential equation in linear form, and now we are here for question number 10. Let's see, question number 10 is simply here dy by dx minus 2xy equals x. So comparing this with linear form, we get here p as minus 2x, q as x. Now let's find the integrating factor. It is simply e power integration p dx, which gives here e power minus x square, and multiplying both sides by e power minus x square, will get here e power x minus x square, means 1 by e power x square. So we'll get here e power minus x square dy by dx minus e power minus x square into 2x into y equals x into e power minus x square. Now taking LCM, will get here derivative of y into e power minus x square minus 2x into e power minus x square y into dx equals x into e power minus x square dx. Now left hand side is derivative of y into e power minus x square, and right hand side is simply x into e power minus x square into dx. Integrating both sides, will get here y into e power minus x square equals integration of x into e power minus x square dx, and derivative of e power, if you find derivative of the power of exponential function, simply that is minus x square, it is minus 2x. So we can write here in right hand side, so minus 1 by 2 into minus 2, multiplying and divide by minus 2, will get simply as in right hand side it is integration of e power minus x square, and also we'll get here minus 1 by 2 e power minus x square on right hand side plus c, and then simplifying, we'll get here y equals e power x square into minus 1 by 2 e power minus x square plus c, which is simply minus 1 by 2 plus c into e power x square. And this is the solution for question number 10. Now let's move to question number 11, and it is here dy by dx plus y by x square equals 1 by x square. Okay, question number 11 is here. Dy by dx plus y by x square equals 1 by x square. So comparing this with linear form, we'll get here p equals 1 by x square, q equals 1 by x square. So integrating factor will be e power integration b dx. So we'll get here e power integration 1 by x square dx, which is simply into e power minus 1 by x. So multiplying both sides by e power minus 1 by x, we get e power minus 1 by x into dy by dx, and then e power plus e power minus 1 by x square into y equals e power minus 1 by x square. Taking LCM, we'll get here e power minus 1 by x into dy plus e power minus 1 by x square into y into dx equals e power minus 1 by x whole divide x square into dx. So left hand side can be written as y into e power minus 1 by x, derivative of y into 1 e power 1 minus 1 by x, and right hand side will be simply here e power minus 1 by x square dx. So now integrating both sides, will get here y by e power 1 by x equals integration of e power minus 1 by x square dx, means simply it is because derivative of power of exponential function, that means derivative of minus 1 by x is 1 by x square. Okay, so if you differentiate e power minus 1 by x, you will get here 1 by x square, which is in product with e power minus 1 by x. So we'll just by if you have any confusion, you can use substitution method. You can put y equals 1 e power y equals 1 by x and then differentiate, and then after that simplify to find the integration. You will have the same thing. So by integration, we will get here e power minus 1 by x plus c on right hand side, and then by simplification we will get here y equals 1 plus c into e power 1 by x. This is our answer for question number 11. Now let's move to question number 12, and here it is, the question number 12. So 1 plus x into dy by dx minus xy equals 1 minus x. So dividing both sides by 1 plus x, will get here dy by dx minus x by 1 plus x into y equals 1 minus x by 1 plus x. So comparing this with linear equation, so we'll get here p equals minus 1 by 1 plus x, q equals 1 minus x by 1 plus x. So let's find the integrating factors. So it will be e power integration of p dx, that is e power minus x by 1 plus x. So now to integrate this, we'll add here minus 1 and plus 1 in numerator, so that it will be easy to integrate this. So now let's separate this term. So it will be here minus 1 plus 1 by 1 plus x square, and which can be easily integrated as minus e power minus x plus log 1 plus x, and which is e power minus x times e power log 1 plus x, and that is simply e power minus x into 1 plus x. Multiplying both sides of equation 1 by 1 plus x into e power minus x, we'll get here 1 plus x e power minus x into dy by dx, and then 1 plus x. So e power minus x into minus x into y equals 1 minus x e power minus x. So we'll try to change left hand side as derivative of two function. So let's see here, first term is derivative of y into 1 plus x into e power minus x, and then minus e power minus x into 1 plus x into y. So we can see here derivative of e power minus x into 1 plus x is simply, if we use here product rule, we'll get here derivative of e minus x is simply e minus x, and then times 1 plus x will be there, so we'll get here e power minus x and plus x e power minus x, and then after that we'll get here plus e power minus x, and e plus minus will be cancelled, we'll get here same. So it's very simple, you can understand that, or you can try by yourself. So as I told you, always left hand side will be changed as y into integrating factor, derivative of y into integrating factor. So let's find, let's integrate both side with respect to x. So we'll get here integrating both side. If integrating both side, we'll get here y into 1 plus x into e power minus x in left hand side, which equals integration of 1 minus x into e power minus x dx. Now we have to use integration by parts on right hand side, so that we'll be getting here as 1 plus x into y into e power minus x, as integration by parts is here simply first function into integration of second function. So we have to follow this late rule, LATE, that means exponential should be considered as a second function. So algebraic function is first function into integration of e power minus x is e power minus x by minus 1, minus derivative of first function is minus 1, and integration of second function is e power minus x by minus 1. So it will be simply x minus 1 because of minus times e power minus x plus minus minus cancel, so it will be here minus integration of minus e power minus x, so it is e power minus x simply plus c, and then by simplification we'll get here 1 plus x into y equals x minus 1, and then plus 1 plus c into e power x plus minus cancel, so we got here 1 plus x into y equals x plus c into e power x as our answer. This is solution for question number 12. Okay, so my dear students, in this video we are solving problems of integration, we are solving problems of differential equation in linear form. Okay, so hope you are enjoying this, and if you like this video, please share among your friends. Okay, and like and subscribe my channel. So, and if you have any confusion or if you have any suggestion, please you can please you share with me, write it in comment box also. Now let's move to question number 13, and question number 13 is x into dy by dx plus 2y equals x square log x. So dividing both sides by x, we'll get here dy by dx plus 2 by x into y equals x log x. Okay, so by comparing this with linear form, we'll get here p equals 2 by x and q equals x log x. So let's find the integrating factor, so that we'll get here integrating factor as e power integration p dx, which gives here e power 2 by x dx, which is 2 log x. E power 2 log x means e power log x square, and which is x square. Okay, so multiplying equation 1 by x square on both sides, will get here x square dy by dx plus 2x into y equals x cube log x. Okay, so now we can write here left hand side as derivative of y into x square on taking LCM and simplification, and the right hand side will be simply x cube into log x into dx. Now we are integrating both sides, so we'll get here x square into y on left hand side. Now in right hand side we have to use integration by part. For that we will take u as log x. Okay, so because we have to follow the rule LATE, that means log should be taken as first function. So first function into integration of x cube is x power 4 by 4 minus derivative of log x is 1 by x, integration of x cube is x power 4 by 4, which gives here simply x power 4 log x by 4 minus 1 by 4 will be there, and x cube, integration of x cube is x power 4 by 4, so it will be simply minus x power 4 by 16 plus c, and therefore dividing both sides by x square, we will get here y equals x square log x by 4 minus x square by 16 plus c by x square as our answer. This is our complete solution for question number 13. Let's move to question number 14. Okay, so question number 14 is here: y dy by dx plus y equals xy square. So at first I told you that p and q must be function of x or constant only. Okay, but here we can see it is function of y square. That means we are getting y square in right hand side. So let's divide both side by first y square. Now in this case, as we discussed at first, that in this case we'll suppose z equals 1 by y, and then we'll differentiate this with respect to x, so as to get minus 1 by y square into dy by dx, that is minus y power minus 2 dy by dx, that is minus dz by dx equals y power minus 2 dy by dx. Now substituting this value in equation 1, we'll get here dz by dx equals, so because of minus we'll get here minus dz by dx plus z 1 by y is z equals x. Now if we take here minus common, so we'll get here dz by dx minus z equals minus x. Okay, and this is in linear form. Okay, so by comparing we'll get here p equals minus 1 and q equals minus x. So integrating factor will be e power integration p dx, which gives here e power minus x, because integration of minus 1 is minus x. Multiplying both sides by e power minus x, will get here e power minus x into dz, and taking LCM also we are getting here e power minus x z dx equals minus x e power minus x dx. So left hand side becomes left hand side can be written as derivative of z into e power minus x. So you can check here derivative of first and second function, derivative of second function into first function, and in right hand side we have just simply we have minus x into e power minus x dx. Now integrating both sides, we'll get here z into e power minus x equals, in right hand side let's use integration by parts. So derivative of first function minus x, derivative of, so using integration by parts on right hand side, first function into integration of second function minus e power minus x, minus derivative of first function is minus 1, and then integration of second function is minus e power x and dx. So let's substitute the value of z. So z is 1 by y e power minus x, in left hand side equals x minus minus plus x times e power minus x, and minus minus plus e power, and then into minus is minus, because and my integration of minus integration of e power minus x is minus e power x. So because of minus, again we will get here plus. So right hand side will be x into e power minus x plus e power minus x plus c. Dividing both sides by e power minus x, will get here 1 by y equals x plus 1 plus c into e power x. Now on simplification, we'll get here xy plus y plus cy e power x equals 1 as our answer. This is the solution for question number 14. Now let's move to question number 15, and the question is here: y dy by dx equals y tan x equals y cube sec x. So we can see here p and q are not only function of x. Okay, we are getting here y cube, so and y there also. So let's divide, so let's remove y cube. So dividing both side by y cube, we'll get here minus y cube, 1 by y cube means e power minus 3 dy by dx, and dividing both side by y cube, you will get here y power minus 3 dy by dx plus y square tan x plus y power minus 2 tan x equals sec x. Now let's put here y power minus 2 equals z, that means 1 by y square as z. Then we'll get here dz by dx equals minus 2 y power minus 3 and dy by dx. So from that we'll get here y power minus 3 dy by dx equals it will be here minus 1 by 2 dz by dx. So okay, so from substituting these two values, the value of z and dz by dx in equation 1, we'll get here minus 1 by 2 dz by dx plus the value of z is y power minus 2, so it is here z tan x sec x. Okay, so equals sec x. Now multiplying by minus 2 on both sides, we will get here dz by dx equals dz by dx minus 2 tan x into z equals minus 2 sec x. Now we can see that this equation 2 is in linear form. So we, by comparing, we'll get here p equals minus 2 tan x and q equals minus 2 sec x. So indicating factor will be e power integration p dx, which gives here minus 2 and integration of tan x is we know that it is the value of p is here e power minus 2 tan x dx, and integration of log x is integration of log x is log sec x. So we'll get here indicative vector as minus e power minus 2 log sec x, which is simply e power log sec power minus 2, that is 1 by sec power minus 2 is 1 by sec square x, which is 1 by sec square is 1 cos square x. So e power cos square x will get here. So e power log cos square x, and which is simply cos square x. So multiplying both sides by cos square x, will get cos square x dz by dx minus 2 sin x by cos x means sin x, 1 cos and cos cancel, so here and cos x into z equals minus 2 sec and cos will be cancelled, so we will get here minus 2 cos x. So we can easily see that left hand side is derivative of z into cos square x. So derivative of z is dz and derivative of cos square x is minus 2 cos x and sin x. Okay, so now and taking LCM, we have the result as derivative of z into cos square x in left hand side, which equals minus 2 cos x dx in right hand side. Now integrating both sides, we'll get here z into cos square x equals minus integration of cos x dx. So that is 1 z, the value of z is 1 by y square. You can see there we have substituted 1 by y square as z, so it is 1 by a square cos square x, integration of cos is sin x, so minus 2 sin x plus c. And now we can write here cos square x equals c minus 2 sin x into y square. Therefore our answer is c minus 2 sin x into y square equals cos square x. Okay, so just by simplifying, do the cross multiplication, we'll get here cos square x equals c minus 2 sin x into y square. Therefore we can write the answer as c minus 2 sin x into y square equals cos square x. And this is the solution for question number 15. My dear students, in this video we have discussed about differential equation in linear form, and we have solved 15 questions. Hope you understood this, hope you enjoyed this. My dear students, if you have any confusion, please share with me, please write it in comment box, and please like and subscribe my channel. Keep watching, keep learning. Thank you so much. God bless you.
Thank you so much for watching my video. I I hope you like this video. Please do share this video with your friends, in your circle, in your social media, and please don't forget to subscribe my channel. Thank you so much. God bless you.